Hello YouTube, it's now time for another project, and this time I've been working with the XV-11 LIDAR sensor. This is a laser rangefinder I found on a Neato vacuum robot vacuum cleaner. This is one of the more inexpensive modules compared to normal LiDARs, which easily comes as $400 and $1,000. But this is a cheaper module to get hands on. The great thing about this module is that it's powered by about 5 volt, and it uh, just uses a standard UART connection with the 115200 bow, so that's perfect, though it spits out quite a lot of data to be processed. So for this I decided to use an STM32. This is the STM32F429 DISCOVERY board, which has the processor on the back and some SD RAM, and then a touch display. For this project I've actually decided to make it wireless, so it scans and it is battery driven, and I also put a Bluetooth module on here so I can send the data to the computer to display. But I've also implemented the display of the range, the distances that's coming back from the sensor to be displayed on the actual display here. So let's have a look at the project in action. The first thing we have to do is to connect the battery lead to the STM32, and as we do so, we'll see that the LiDAR starts spinning. Now that the LiDAR is spinning, we will also see that on the display, we actually have the LiDAR information shown. So if I turn it like this, it will correspond to the actual LiDAR data. I can then move around and we will see the room being scanned. As I move into a more darker room, we'll still see that the LiDAR catches the room quite well. And back at the computer, we can then try, instead of showing the data on the screen, we can try and start our MATLAB script, which will wirelessly connect to this to the Bluetooth module on the back. We'll see that this module will turn red eventually instead of blinking. There we go. And on the computer, we'll see the same LiDAR data as on the actual display. So I'll just turn it. We'll see here that it's the same as on the computer. And I can go around again, and the data is wirelessly transmitted to the PC. At a bit slower rate than on the display, but it is transmitted. Okay, one final feature that I've implemented is the way of doing calculations on the display itself. So let's go out again and find a nice spot where we have our room. You can raise it up a bit. And here we have a scan of the room. You can see me at the back here. That's me. The blue dot is the scanner, and then we have the white line behind. That's me, and then we have the room. So now let's say that I would like to know the distance from one of the edges to another. Actually, to use this device as a range scanner to figure out the distance. So I pause the scan. Now it's paused. I can move, but nothing would happen. And then I can press and select a spot on the display. Select another one, and it will tell me the distance. So across here we have 227 centimeters, and on the other way, can select again a new measurement. there is 404 meters. Alright, I can resume the scan and go into another room, do the same thing. And here we have a room. We pause the scan. We measure from one edge to another, about 330. Yep. And from that end to the other is about 4 meters. So in this way we can actually use the laser scanner to get measurements of different rooms. So with this project working, we can just display how and what the LIDAR information can be used to. But the plan is actually to mount this LIDAR sensor on a robot. In first case, it will be an omni-wheel robot, and then use the LIDAR information to autonomously navigate it around the room. But in the end, our final goal is to mount this LIDAR on our quadcopters to make a 100% fully autonomous quadcopter by the use of GPS, the IMU sensors, LIDAR for edge detection, and then finally an optical flow sensor to detect the ground even more precise than the GPS signal. So that's the plan, and this is just a small project on how to use and interpret the data coming from the XV-11 LiDAR. Thank you for watching.